Last class I have covered settlement of pile group. The settlement of pile group we can divide into two parts: elastic settlement because of pile material, then settlement of soil supporting pile. There are three cases. One is friction pile, second is your end bearing pile, third one is your combined pile. That means both friction and end. In friction piles, particularly when you will say it is a friction pile, when it is a homogeneous soil, then you can say it is friction pile, and up to a greater depth same soil will be there. In that case, total load is assumed to be act at a depth of equal to 2/3 of your pile length. Second one is your end bearing. Suppose there is a weaker soil strata, below this there is a very strong strata is there, then what will happen? Pile has been inserted and rest on the strong strata. In that case, to find it out the settlement, so total load is assumed to act at a depth equal to the length of the pile. It will act at the bottom, that means below the length of the pile. Combine both friction and end bearing. So if it is a combined pile, so suppose layer 1, layer 2, L1 and L2, L1 part has been taken out. In L2, the load will be acted from the 2/3 of your L2. We will solve a problem. This is the example, one example. Let me start with this. There is a load in the pile group is coming about to be 2000 kilonewton. In this 2000 kilonewton load is coming. So there is a water table below the 3 meter. Water table, gamma is equal to 16 kilonewton per meter cube. Then below 3 meter there is another soil, that is your 2 meter, gamma is equal to 19 kilonewton per meter cube. Then this will be your 3 meter. So total is your 8 meter soil is there. Then below 8 meter the pile embedded length is your, from here to here is your 12 meter. So then from here you have a 10 meter. In 10 meter what are these? This is your layer 1. What are the properties has been given? Gamma saturated is equal to 20 kilonewton per meter cube. Cc is equal to given 0.25. E0 is equal to 0.75. Then below this there is 10 meter. 10 meter. This is your layer 2. Gamma saturated is equal to 21 kilonewton per meter cube. Cc is equal to 0.02. E0 is equal to 0.65. So this pile group is embedded in a homogeneous soil. That means these are all your friction piles. If total length is your 12 meter, so 2/3 of your 12 meter is how much? 2/3 of L. If you come back to here, generally it is your 2/3 of your pile length. If I am considering 2/3 of the L, 2/3 into 12, 8 meter. So, particularly below 8 meter, if I am drawing here 8 meter, the entire load will be transferred because it is a friction pile, given its friction pile. Below 8 meter I put it. Now, this will be your, this is your layer 1, this will be generally 1:2 and this will be 1:2. So, at the center this is A and at the center this is your B, layer 1 and layer 2, both the layers having 10 meter depth. Now, let us start this solving this problem. This is a friction pile example. Sigma 0 at point A, middle of the layer 1, sigma 0 at point A, which is equal to 3 into 16 plus 2 into 9.0 plus 8 into 10.0. Water table is at here 3 meter. Above the water table it will be 3 into 16. Then below the water table it should be submerged unit weight. So, it will be 2 into 19 minus 10, it is 9. Then below this will be 8 meter. Up to this depth, if I am taking it for layer 1, this will be 5 plus 3, 8. From here to here is your 8 meter. So, this will be your 8 meter. So, 8 into gamma saturated is equal to given 20, 20 minus 10, that is your gamma submerged 10, which comes out to be 146 kilonewton per meter square. Similarly, sigma 0 at B, overburden pressure at B, which is equal to 3 into 16 plus 2 into 9.0 plus 13 into 10.0 plus 5 into 11. 13, because this is your total 10 plus 3, this from here to here will be 13 meter, that is why 13 into 10, and at the middle it is 10 meter, 5 into 11, it is 21 minus 10, that is your 11. It comes out to be 251 kilonewton per meter square. Now, cross sectional area at A, which is equal to 2.5 plus 2 into 5 into half, which is equal to 7.5 meter square. So, delta sigma is equal to 2000 divided by 7.5 into 7.5, which is equal to 35.56 kilonewton per meter square. Similarly, cross sectional area at B, which is equal to 2.5 plus 15 into 2 divided by 2, which comes out to be 17.5 meter square. Now, delta sigma comes out to be 2000 divided by 17.5 into 17.5, which is equal to 6.53 kilonewton per meter square. For settlement layer 1, consider layer 1, which is equal to rho is equal to Cc h by 1 plus E0 log 10 sigma 0 plus delta sigma by sigma 0, which comes out to be 0.135 meter. Similarly, for layer 2, rho is equal to settlement, it comes out to be 0.014 meter. So, total settlement is, total consolidation settlement, total consolidation settlement, which is equal to 149 meter. I hope you can get it. This is a pile. Once again, pile group has been given 3 by 3 and load coming on the pile group will be 2000 kilonewton. How it has been classified as a friction pile? If you look at here, subsoil profile is of kind of same soil up to a large extent. That is why this pile has been classified as a friction pile, and gamma 16, gamma 19, gamma 20, 21 has been given. So, what I did, there are two layers, compressible layer, clay soils 10 meter and 10 meter, and at the center what is your overburden pressure sigma 0 at A and B has been calculated. Then cross sectional area at this point, cross sectional area at this point, based on that delta sigma has been calculated. Then settlement of the consolidation settlement of the layer 1 and consolidation settlement of the layer 2 has been calculated. So, total settlement is comes out to be 0.149 meter. Now, this is a example. I solve it considering a pile group settlement for this. Now, let us start a new part, that is your negative skin friction. Try to understand the terminology of the negative skin friction. Let me draw a figure. There is a pile. In the pile has been embedded in a soil. There are two soils. One is your natural soil, and this is a field of soil or loose soil. Field soil or loose soil. So, this height has been marked as ln. What is the negative skin friction? When the field of soil starts consolidating, under its own overburden pressure, it develops a drag on surface of the pile. The drag on the surface of the pile is called negative skin friction. If you look at here, suppose there is a natural soil, pile is there, then above the natural soil there is a field soil or loose soil. So, what will happen? It will start consolidating because it is a recent filling soil under its own overburden pressure. Then what will happen? It will develop a drag in a opposite direction or the direction of the loading. So, if you look at here, Q has been applied here, then this is your frictional resistance, then it is in the direction of your loading. This is called your negative skin friction. So, what are the conditions for negative skin friction to be developed? conditions. First one is fill material. If there is a fill material of loose state, second one is if there is a water table and all of a sudden you load the water table, lowering the ground water table. Also, when fill is placed over peat or soft clay strata, so these are the conditions when negative screen friction occurs. Let me draw it once again. There is a group of pile, in group of pile. So, there are 3 layers. One is your field of soil, then this is your soft clay, then there is a natural soil here. In this case, what will happen? If you look at here, there is another case, there is a natural soil, then in between there is a soft clay, then there is a field of soil. So, there are 3 conditions. If fill material is in the loose state or there is a water table here, all of a sudden you lower down the water table from the ground surface to below the ground surface at the bottom of the pile. In that case, self consolidating will occur. Then drag load will be in the opposite direction, that means in the direction of the loading. When fill is placed over a peat or soft clay strata, these are the case. Now, how to calculate negative screen friction for single pile? First one is your, let us say, A single pile. In single pile again 2 parts, one is your for cohesive soil, in cohesive soil negative screen friction is equal to P ln into S. Ln is equal to length of pile in the compressible material. S is shear strength of the cohesive soil. P is equal to perimeter of pile. So, negative screen friction is equal to P, perimeter of the pile, pi d into L. Ln is equal to, I have shown it, this is the ln, in this case this will be ln. S is equal to shear strength of the pile. Then second part is your for cohesionless soil. For cohesionless soil, it is your half P ln square gamma k tan delta. So, k is equal to earth pressure coefficient which lies between the active and passive earth pressure coefficient. So, delta is your, that is your friction between pile and soil material. It is generally taken between 5/2 to 5. Now, this is for single pile. Let us go for this group of piles. For particularly group of piles, if you look at here, there are two cases to be considered. First one as a single pile, second one considering as a single pile failure, negative screen friction, and considering as a block shear failure. Maximum value used. So, considering single pile failure, so Fng is equal to n into Fn. Fn is your screen friction, negative screen friction for single pile. In a group, how many number of piles? Suppose 3 or 4, this is your number of piles. For as a block, if I consider, it will be S ln Pg plus gamma ln Ag. This includes the volume of the soil enclosed in the group. The volume of the soil enclosed in the group, n is equal to number of piles in a group, gamma is equal to, let us start with this. So, gamma is equal to average effective unit weight of soil within the pile group up to depth ln. Pg is equal to perimeter of pile group, Ag is area of pile group, S is equal to shear strength, if there are fine group of piles considering as a single pile failure, negative screen friction into multiplied into n number of piles, you can find it out. Considering as a block failure, you can find it out, and here the capacity will be maximum value to be used. Earlier it was a minimum value, here for negative screen friction it is maximum value to be used. There are another case, suppose a case is here L1, L2, L3, there is a capacity here. So, this is farm strata, there is a fill soil, there is pit. L1 and L2 acted upon by negative skin friction. If you look at here, look at the direction, frictional resistance, here it is in the direction of the load. So, in this case, for considering single pile, considering as a single pile failure, F Ng is equal to N F N1 plus F N2. So, F N1 is equal to negative skin friction of single pile in the field F N2 is equal to negative skin friction of single pile in the pit. Similarly, for group, it is considering single pile failure, N is equal to number of piles. Then considering as a block, S1 L1 Pg plus S2 L2 Pg plus gamma 1 L1 Ag plus gamma 2 L2 Ag, which is equal to Pg into S1 L1 plus S2 L2 plus Ag into gamma 1 L1 plus gamma 2 L2. L1 is your depth of the fill soil, L2 is your depth of the pit soil. What will happen? This negative, why I explain this one, the negative friction is occurring because there are two soils, one is fill soil, another one is pit, both are producing the negative skin frictions. So, layer by layer you have to calculate and calculate your values, then compare with your considering single pile failure, considering block failure, and the maximum value you take into the negative skin friction. This is for you an assignment example. You can try at home, there is nothing big. A square pile group three by 3 passes through a recently filled up soil. The depth of fill Ln is equal to 3 meter, diameter of pile is 30 centimeter. They placed 90 centimeter apart from each other. If soil is cohesive, Qu is equal to 60 kilonewton per meter square. and gamma is equal to 15 kilonewton per meter cube. Find negative skin friction of pile group. This assignment you try at your home and you do it. It is just putting your formula and getting these results. So, more or less I have completed pile foundations basics. Some part I will cover maybe later on. Next class I will start well foundations. Thank you.